Hello, so what are we going to do today? Today we are going to solve a game as an LPP. You remember last time we have seen the theory. Now let us just do the problem involving numbers only. So over here there's a game between two people. This is the pair of matrix where they are having 1 minus 1 minus 1 minus 1 minus 1 3 minus 1 2 and minus 1. Remember that if you have to solve this game as an LPP, firstly, all the values should be positive. That is why what we are doing over here, we are adding this k equal 2 to each entry. So adding k equal 2 over here, you will be getting 3. Similarly, over here, you will be getting 1, 1. To each entry, you are adding the value k equal 2. Okay, so this is what we are going to get. But always remember that you will have to subtract this value at the end. Okay, so since we are going to solve it as an LPP, so let this one A1, A2, A3, P1, P2, P3 and SB, B1, B2, B3, Q1, Q2, Q3 be the optimum strategies. The LPP, if you remember, we can form the LPP for player A as well as for player B. So the LPP for player A is minimum 1 by U. The objective function, it will always be, it doesn't depend on the game. It will always be x1 plus x2 plus x3. Again, you can refer the theory. How did we get this one? But it will always be this. Okay, because we are having 3. Okay, that is why x1, x2, x3. If there are only 2 strategies, then will be only x1 plus x2. Similarly for 4 or 5 strategies. Now, how did I get these constraints? These constraints is just from the columns. From the columns of this matrix. You can see over here 3, 1, 1, 3, 1, 1. Similarly over here 1, 1, 4, 1, 1, 4 and 1, 5, 1, 1, 5, 1. So the constraints are from the columns for player A, where xi equal pi by u. Okay, so these variables, they are equal pi upon u. Okay, so that is the LPP for player A. Now what is the LPP for player B? For player B, the LPP is max 1 by W. Again, it will always be y1 plus y2 plus y3 subject to. How did I get the constraints? You should also take note that for player A, it is 1 by U, and for player B, it is 1 by W. Okay, so subject to these constraints. Okay, these. Okay, how did I get these constraints? It is from the rows of this matrix. You can see over here 3, 1, 1. 115, 141. It comes from this matrix 311, 115, 141. So you remember that for player A, it is the columns, and for player B, it is the rows. Okay, so now what we are going to do, since we have two LPPs, you may think that we need to solve for both, but actually we need to solve only for one player. We will solve it for player B since it is already a maximization problem. You notice that for player A, it is a minimization problem. So we are going to solve it for player B. So the LPP takes this form. You convert it into standard form. Convert all of these into equalities. So you'll be having this just by using the slack and surplus variables. Let me bring it closer. Okay, so just by using S1, S2, S3, just like we did, okay, we can introduce the slack or surplus variables. Okay, so here all of them are slack variables, so this is it. Okay, you can see over here it is max 1 by W, so I've replaced 1 by W by Z. Z equal 1 by W and Yi equal Qi by W. Okay, so once you do it, okay, now you can put all the entries in the simplex table. Okay, you can calculate the basic solution and everything, but you can just easily as well skip it into the table. Okay, so this is the table that we will get. The initial simplex table. You are noticing over here that I am putting over here y1, y2, y3, s1, s2, s3 because over here the variables are y1, y2, y3. Do not make a mistake, this is not x1, it is y1. And over here I am putting capital Y because I've already used the small letters for something else. That is why I'm using the symbol capital Y. Y2, Y3, Y4, Y5, Y6. Okay, again, if I have to repeat, this one, it comes from the objective function 111,111,000. It comes from this objective function 111,000. So the basic variables S1, S2, S3, just like we always do it. Okay, so CB000, it comes from over here 000, corresponding values of S1, S2, S3. And these values, they are directly from this LPP 311,100, 311,100. Okay, so up to solution, it comes directly from the table. After doing that, if you remember, we will calculate Zj just like we did in the simplex method. Okay, I hope you are familiar with the simplex method. Okay, similarly, we can calculate Zj minus Cj. Okay, so calculating Zj minus Cj, you will get this. Okay, Zj minus Cj, you will get this value over here. Okay, after getting this value, you notice that now we have to find the most negative values. You can go with this, or with whatever. It doesn't really matter. We can just choose one, because since all of them, they are most negative, have the same negative value, -1. So you can choose any one. Over here, what I did, I choose this one as the most negative value. So after doing that one, again, I compute the ratio. The ratio is solution by the pivot column. Since this one is the most negative value, so this one will be the pivot column. Okay, so I'm dividing the solution by the pivot column. 1 divided by 3, it's 1 by 3. 1 divided by 1, it's 1. 1 divided by 1, again, it is 1. Okay, now you choose the least non-negative. Okay, I'm saying non-negative because if it's 0 also, you can choose the ratio to be 0. Okay, so over here, this one is the least positive, least non-negative ratio. The least non-negative ratio is this one. So that is why this column over here is this first column. It is the pivot, the row. It is the pivot row. Okay, so this row over here is the pivot row. Okay, after getting the pivot row, what will we do? Just like we always do, remember, now the pivot row and the pivot column intersects at this point. So this one will be the pivot element. Okay, I hope you can see it. Let me just maximize. Okay, so that is the pivot element. Next, what will we do? We will divide the pivot row. The pivot row is the first row, so we will divide it by 3. Similarly, R2, we can do row operations. R2, it will be R2 minus 1R1, minus 1R1. R3, the R3 will be R3 minus 1R1. We are using the pivot row, okay, to change R2 and R3. So after doing that one, again, we will have this table. This table, again, will be the same thing. But over here, you notice that Y1, because this one is the pivot element, so Y1 will now enter the basis. It will replace S1. So that is what I've written over here. Instead of S1, okay, instead of S1, I have replaced it with Y1. So I hope that is clear. The remaining variables, S2 and S3, they remain the same. Okay, so similarly, okay, after doing these operations, we will have this table. You can do it with the simplex method. You can refer the video from it. We will have this table. So again, we will compute Zj minus Cj. We will be having these entries. Again, okay, now after computing Zj minus Cj, now we can choose the most negative value here. Okay, so over here we can simply choose this second one, even though this one and this one, they are most negative. So we can choose this one to be the most negative. It really doesn't matter. It is your choice. Most negative. Okay, so that is why this one will be the pivot column now. This one will be the pivot column. Since this one is a pivot column, a solution divided by pivot column will give you the ratio. 1 by 3 divided by 1 by 3 will give you 1. 2 by 3 divided by 2 by 3 will give you 1. 2 by 3 divided by 11 by 3 will give you 2 by 11. Okay, so this is how we get the ratio. And again, if you notice, this one will be the least non-negative ratio. So this one will be the pivot row. This row over here will be the pivot row. And since that one is the pivot row, the intersection of the pivot column and the pivot row will give you the pivot element. So this one will be the pivot. Okay, so up to that it is alright. So now over here, what will we do for the next table? For the next table, what will we do? We will replace, you are noticing the pivot over here, so y2 will replace s3. Okay, y2 will replace s3. So that is why I'm getting this table. Instead of s3, now I'm getting a new table which I've replaced it with y2. Again, we can do the operations r3 divided by the pivot. The row 3, it is the pivot row. So that is why first we will operate the pivot row, r3 divided by 11 by 3. So this is what we are getting. Similarly, we can change r1. You notice r1 minus 1 by 3. How did I get this minus 1 by 3 over here? It is from this second table, 1 by 3. Minus 1 by 3, r3. Similarly, over here, r2 minus 2 by 3, this 2 by 3 comes from over here. Okay, so after doing that, we will have this table. Okay, again, we can fill this table, y1, s2, y2. You can notice. Okay, so this is what we are getting. Again, after doing all that, we are getting zj minus cj. You can see that there are still some negative values. So now this one, it is the most negative. Now this is the third table. This is the most negative. So this one will be the pivot column. Okay, so after getting this pivot column, again, we can calculate the ratio. 3 by 11 divided by 3 by 11 will give you 1. 6 by 11 divided by 50 by 11 will give you 3 by 25. 2 by 11 divided by 2 by 11 will give you 1. Now we can again choose the least non-negative ratio. So it is this one. So over here, now the second row, it is the pivot row. Since this one is the pivot row, this one is the pivot column, so this one will be the pivot element. Okay, and over here now what will happen is in the next table, y3 will replace s2. y3 will replace s2, so you will be getting y1, y3, y2. Okay, so that is how we are going to get it. y1, y3, y2. And if you notice over here, y1 has a value 1, y2 1, y3 and 1. So that is how we are getting CB over here, the cost vector. Now, again, you notice over here from in this old table, this one is the pivot row. That is why I am operating the pivot row first. R2 divided by the pivot element. R2 divided by the pivot element. Now R1, again we will change. It will be R1 minus 3 by 11 R2. How did I get this 3 by 11? It is from the old table, 3 by 11. And similarly, R3 will be R3 minus 2 by 11 R2. So how did I get this 2 by 11? Again, it is from the old table. So I hope that is clear. Again, we can calculate Zj minus Cj. Okay, if you are done calculating this, so we will notice that now there is no longer a negative value here. Okay, throughout. Okay, 0, 0, positive, positive, positive. So no longer any negative values. That is why the solution ends here. Okay, the simplex table will end here. We no longer have to calculate the ratio. So what will happen here? Okay, this is very important now. Okay, so what I've written over here, since all zj minus cj is greater or equal to 0, we get the optimum solution is this. Y1 equals 6 by 25. How did I get this solution? Y1 is 6 by 25. Okay, 6 by 25. Y2, it is 3 by 25. So over here, Y2 is 3 by 25. Oh, sorry, Y3. This should be Y3. Okay, so see, I made a mistake over there. Over here, it is Y1, Y3. Y3, it is 3 by 25. And Y2. Okay, sorry, I made a mistake. You notice over here that it is not Y1, Y2, Y3, it is Y1, Y3, Y2. Okay, so similarly over here, Y1, Y3, Y2. Okay, it's good that I noticed that one. Okay, and S1 will be 0, S2 will be 0, S3 will be 0 because they no longer appear in the basis. They now behave as non-basic variables. Okay, so their values will be 0. Max Z, it will be y1 plus y2 y3. Okay, this is the objective function, so you can add all of them. You will be getting 13 by 25. Okay, so after getting 13 by 25, but if you remember the original question, it says max Z. Okay, we have found the value of Z, but remember we need W, so Z is 1 by W, so W will be 1 by Z, will be 25 by 13. Okay, but you remember that the ultimate aim for game theory is in finding the probabilities and the value of the game. Okay, so that is what exactly we are doing over here. Q1, it will be WY1. How did I get this? It is from what we've written before. Yi equal Qi by W. So that's why Q1 will be WY1. Okay, Q1 will be WY1, Q2 will be WY2, and Q3 will be WY3. Okay, so you can substitute the values, we will get this. Okay, but I just have to make some changes over here. This one will be 4. Okay, because I made a mistake before and place Y2 and Y3. Okay, so that is why we will be getting this. Okay, now, okay, so Q1, Q2 and Q3, they are the solutions for B. Okay, these are the probabilities for the player B. But if you remember from the very beginning, again I said that just by solving the game for B, we will be able to also solve the game for A indirectly, because player A, the game for LPP and for player A and B, they form a primal dual pair. Okay, one is a primal LPP, the other is a dual LPP. So now we will get x1 equal 12 by 50, x2 equal 6 by 50, x3 equal 8 by 50. How exactly did I get these values? It is from this very last table. Okay, this very last table, you're noticing over here, S1, it is 12 by 50. So it's like, this works when when two LPPs form a primal dual pair. Okay, so you are solving it for the primal LPP, which is the primal LPP, it is for B. So the solution for the dual LPP will be from these columns. So x1 will be 12 by 50, x2 will be 6 by 50, this one is 6 by 50, and x3 will be 8 by 50. Okay, so the solutions for player B, it is over here. The solutions for player A, it is over here, x1. So that is what I've written. x1, it is 12 by 50. x2, it is 6 by 50 from this value, and x3 is 8 by 50. Again, this one can be obtained from the last table because they form a primal dual pair. So now we can calculate P1. P1 will be Wx1, Wx2. You are noticing over here, again, I am using W instead of U. If you are taking a look over here, okay, I've written Xi equal Pi by U. Okay, but again, this one, it is relating to that. Primal dual LPP, it will behave in a similar way. Okay, instead of U, we can easily replace it by W. P1 equal Wx1, P2 equal Wx2, P3 equal Wx3. We can substitute the values. We will be getting this. The value for W is here. Okay. Now this. Lastly, the value of the game, it is W minus K. Again, you remember that from the very beginning, we have added K equal to this game, so it will be positive. In the final value of the game, we have to subtract again this minus 2. So after subtracting, you will be getting minus 1 by 3. Okay, so the value of the game, it is minus 1 by 3. So we can easily say, because it is a negative value, so this game that we were having from the very beginning, it is favorable for player B. Okay, B will earn a profit because it is a negative value. Okay, so I hope that is clear. Until next time.